incredible forces of nature meet, where fire and ice battle to build and then destroy landscapes, where the violence of nature can wreak its havoc over centuries or seconds. A land of brutal beauty. Alaska. Alaska is a ruthless ice-making machine. This is Mount Muir. It rises above one of more than 100,000 glaciers covering America's last great wilderness, and one of the least accessible places on Earth.
I've done this thousands of times all over the world, South America, Himalaya, everywhere, but I've never done it in Alaska. This is gonna be big. 10 seconds.
This landscape may look static, but it isn't. Everything here is shaped by constantly moving ice. In just 24 hours, a single glacier can move up to 80 feet. An astonishing 20,000 trillion tons of ice slide across Alaska every day. Alaska is a place that tells the remarkable history of our planet. And what is happening there now can point to the future. At its most northerly point, Alaska is just 900 miles from the North Pole. It's the coldest place in the United States, with temperatures down to -75. It has North America's highest peak. And we're still learning what this place can tell us about changes sweeping our world. To understand it takes a new kind of scientist, one who'll go to extremes to get answers. Alaska is a mystery that can't be solved in the lab. To crack it, you have to live it.
It takes everything from you to fly here, that's for sure.
Alaska is unique, created by a perfect collision of the Earth's forces. Close to the North Pole makes it cold. Close to the sea makes the air moist, fueling heavy snowfall. It creates glaciers up to 1,300 feet deep and 129 miles long. They're so huge that they rupture under their own weight. The stresses in the glacier form deadly crevasses. This glacier is 25 miles long, 5 miles wide, 1,000 feet deep. All that space, yet for adventurer Will Gadd, landing on it is still tough.
Now I gotta worry about landing. The only landing zones I can see are about 10 feet square, with big crevasses all around them. There is no good place to land down there.
Landing on ice can be lethal. 1 foot wrong means a 160-foot fall into one of those crevasses. He'd be dead before he even knew he'd slipped up. Geologist Peter Heusler faces his own battle to get in and meet up with Will. Potentially fatal hazards are everywhere. Submerged ice could tear Peter's boat apart. All this ice started life in a glacier. Alaska's glaciers hold 500 trillion gallons of fresh water. There's enough in this one glacier to cover Manhattan to a depth of 5,000 feet, more than 3 times the height of the Empire State Building. Over millions of years, these glaciers have shaped our planet, a delicate balance between geology and climate. To know why, you need to know how they were born. Peter Heusler and Will Gadd are going to find that out.
Yeah, glad to meet you, man. All right.
A glacier is astonishing, solid as a rock, yet formed from some of the softest material on Earth: snow. To understand this transformation, you have to get inside a glacier. The only way in is down the sheer sides of a giant crevasse. It's summer, and the ice is unpredictable, especially at the top. This is the most dangerous part of the glacier.
I'm not so elegant going over the edge here.
Elegance is overrated. All right, here we go.
Up here, the top layer is the accumulation zone, where the glacier forms. Look inside, and you can see where it comes from. Snowflakes fall, layer on layer, and fuse together, binding into a single block of ice. But at this depth, the change from snow into glacial ice is not complete. As they climb, the wall becomes unstable under the Alaskan sun.
Top 6 inches of ice is just really slushy. Hear that roar down there, eh?
Below them, the melting glacier is being carried away in a powerful melt stream. They can't see it, but they can hear it. It's a killer. If they fall in, they'll be swept away.
Oh, stay there!
At least down here, the ice is stronger.
Yep.
It's the second stage in the transformation of a snowflake to a glacier. Years of further snowfall bury the snowflakes. The pressure of the mass of new snow above fuses the snowflakes together. Air is forced out until there is nothing left except solid, blue water ice. Crushed by the huge weight of the ice above, this is the strongest and hardest kind of all. The deeper they descend, the harder the ice gets. This is how a glacier is born. This is the powerhouse of the glacier, and there's an extraordinary clue down here. Layers of dirt buried in the ice.
You got all the dirt in the bottom of the stream path there.
Yeah, he put a lot of it in there.
These tiny particles are not part of the glacier. They're evidence of the inconceivable power of this ice giant. Pieces of mountain ripped from its surface and ground to dust by the glacier. How can it do this? It looks immovable. It's not. Under its own enormous weight, the entire glacier flows down the mountain like a slow-motion river. Bulldozing its way down, the glacier rips the mountain's surface away. It wears it down to rubble, then to sand. Snowflakes, landing at the head of the glacier, take 250 years to travel all the way down to the end, tearing away the mountain it sits on. The birth and life of a glacier is astonishing. What it does to a mountain is epic. It's been happening for millions of years. But as Alaska's ice scythes through the landscape, another terrifying geological force is also at work. And this is one that builds and destroys with extraordinary violence. Alaska is a landscape in constant change. Some of Alaska's glaciers are millions of years old, yet some of its rock can be formed before your eyes. For Alaska contains 41 active volcanoes, and the most dangerous is Mount Augustine. It's so unstable, the U.S. Geological Survey has to monitor it 24 hours a day. Augustine's evidence of something big. It's part of a chain of volcanoes, 2,600 miles long, the Pacific Ring of Fire, containing more than half the world's active volcanoes. This boundary on the Earth's crust releases unimaginable energy, punching molten rock through from 9 miles down. And Augustine is still active and close to boiling point because a year ago it erupted. 13 colossal explosions over 2 months. Ash shot 45,000 feet into the sky. When the smoke cleared, Augustine had grown by 100 feet. Volcanologist John Power spends his life on live volcanoes. It's his job to monitor Augustine. This mountain is alive.
This is basically a thermometer. It's specially designed with this probe. This ground is actually quite hot. And if we were to dig down a little bit, we'd have no problem cooking some potatoes, making a nice soup, maybe scrambling some eggs.
Augustine is so active that the smoldering ground under John's feet is brand new. John is the first to have set foot here. Now, incredibly, somebody wants to ski down it. Lel Tone is an extreme skier, and Mount Augustine has lured her. She'll be acting as a geological guinea pig in one of the most violent places on Earth, and she'll be up against the extraordinary forces of an ice volcano. Today, she'll be skiing not just fresh snow, but the newest piste on the planet. It could not be more dangerous. The danger is not an avalanche, it's called a wet slide. where the entire slope crashes off the face of the mountain, and one is overdue. To understand the full danger, Lel needs expert advice. Back from his survey of the summit, John Power has up-to-the-minute information for Lel. What he knows is the difference between life and death.
It is fairly active. There was a major eruption here just last year, and I imagine the snow conditions there would be quite poor. What I'd recommend is we take off, do a couple loops around the summit, let you guys look at the overall conditions and the different phases of the volcano.
Despite the warmth beneath their feet, the air is minus 15. The snow barely holds firm over the warm ash. Beneath that, hot rock. Beneath that, boiling lava. This moment has been a long time coming. Massive forces within the Earth, acting over millions of years, have pumped up this volcano. This is what it's taken to create this extraordinary slope. Skiing could be enough to disrupt the surface and cause an epic avalanche. Or worse, the wet slide.
3, 2, 1.
Her team dynamite the slope to see if they can trigger anything.
Fire in the hole.
The snow's holding for now. But the dynamite isn't a guarantee. Nothing is with geology this fragile. The snow lies on hot volcanic ground. If it melts where they touch, a chain of events will lead to that deadly wet slide, where the entire snowfield will slide off, carrying her with it. It will take Lel 1.5 minutes to descend this slope. An avalanche will cover this distance in just 40 seconds.
I think I can see her.
The fragile slope has held firm. But every few decades, soon after eruption, the huge slides of snow, rock, and ash will occur, taking 1/10 of the mountain away. The forces that shape this Alaskan landscape are so powerful that soon Augustine will erupt again. But volcanoes are not the only way that mountains are built in Alaska. There are even more ancient and powerful forces at work here. Glaciers and volcanoes are still shaping Alaska with their enormous power, transforming the landscape, often before our very eyes. But there is one constant that has been here for billions of years, and it is one of the most phenomenal natural wonders of all. It's so spectacular, people will go to extraordinary lengths just to see it. It has to be dark, the sky must be clear, and even then, it takes patience. This doesn't happen every day. An incredible collision of physics and geography, that illuminates the night sky. The Northern Lights. What creates this astonishing sight? It comes from the sun, 93 million miles away. Charged particles spat out of the sun at hundreds of miles per second, stream towards Earth. They hit the Earth's magnetic field and are bent towards the poles, where they are sucked into the atmosphere. They smash into the molecules that make up air, and these collisions light up the sky, forming the Northern Lights. Alaska is the site of the planet's most primal geological forces. Alongside glaciers and volcanoes, it's home to the greatest mountain range in North America. What created these? Peter Häusler, geological super sleuth and extreme mountaineer, knows where the answer lies. He's heading into the treacherous mountains to find out. It's a place he knows well. This is his laboratory. At 8,000 feet, the Alaska Range blasts into view. The heart of America's final frontier stretches 600 miles. Home of America's tallest peak, Mount McKinley. At just over 20,000 feet, it dwarfs everything else.
Every time I come in here, I'm just awed by how large the scenery is, and I never seem to remember it well enough.
But in the middle of nowhere, treacherous mountain weather is never far away.
So, Paul, how's it looking to you out there?
It's blowing down there. Might be too windy to land down here.
Bad news. It's too dangerous to land where they want. The mission just got tougher.
Plane's getting buffeted around a little bit, so there's actually a chance we may not be able to land because it's so windy.
They need a safe alternate site. If the weather closes in, they'll have to abort. They spot a snow-covered glacier. It's their only chance.
Does this look okay for landing down here?
Be a little bumpy, but
They set down in the shadow of Mount McKinley. The alternate landing site leaves Peter miles from his destination. He'll have to hike for hours over treacherous ground to reach the rocks he's looking for. Peter's used to it. It's what it costs to find the evidence.
Being a geologist is a lot like being a detective or a forensic scientist at the scene of a crime. You're trying to figure out what happened and who done it.
He hopes the evidence that explains where these colossal mountains came from is here. Peter's search for clues takes him thousands of feet up. One slip could kill. Then there are avalanches, always at the back of a climber's mind. Finally, he finds what he's come here for. The last thing you'd expect to find at the top of a mountain. the fossil of a shellfish. But Peter's 15,000 feet up. How did the fossil of a creature that lived underwater end up here? There's only one possible, extraordinary explanation. 50 million years ago, this was the bottom of an ocean. What force is capable of such extraordinary change? Peter believes it was a colossal collision between two of the massive continental plates that all land sits on, the Pacific Ocean plate and the North American plate. The power of the plates colliding punched molten lava through from inside the Earth, forming volcanoes. And the North American plate buckled upwards like a slow-motion car crash on a cataclysmic scale, creating the Alaskan mountains we know today. But there's yet another astonishing change to Alaska. In the last 50 million years, it's been transformed. The landscape changed beyond recognition. It was once a warm tropical paradise. Hidden beneath the surface of Alaska is the evidence of this lost world. Evidence that makes Alaska so wealthy it can actually pay people to live here. Oil. 50 million years ago, this was a land of huge tropical forests. But then tropical life died out, including those great forests. But they weren't lost, just buried, cooked and crushed beneath Alaska for 50 million years. Those ancient forests transformed into more than 30 billion barrels of oil. What killed off these tropical forests? Movement of the continents changed weather patterns and triggered a global shift in the climate. The oceans cooled and the poles iced over. Ice reached down as far as Alaska, turning it into a frozen wilderness. Over the last 60 million years, Alaska's seen huge changes. Ancient landscapes are buried beneath the ice, but alongside them lie other secrets, which are only being revealed to us today. One of the people uncovering them is scientist Tom Douglas. He operates on the edge of the Arctic Circle, where it's winter all year round.
Okay. It's early morning, the sun's coming up. We've got a full day ahead. We're heading out to the edge of the ice.
Tom's heading for the edge of the frozen Arctic Ocean on Alaska's northern coast. Just 900 miles from the North Pole, they're at the northernmost tip of the U.S. Tom believes the Arctic Ocean has experienced many dramatic changes. The last one transformed America forever. The evidence is locked in ice-cold soil at the edge of a frozen sea. He's excavating ancient timbers, not a lost forest from Alaska's tropical past, but the remains of some kind of building preserved in the frozen ground.
Well, they used to be pretty stably locked in permafrost, frozen in time, basically.
What he's uncovering is evidence of an ancient settlement. Who lived in this place, and where did they come from? 10,000 years ago, an ice age gripped the world. As water was transformed to ice, sea levels fell, changing the geography, revealing a stretch of land from an unknown world to the west. A world of humans. It's called the Bering Land Bridge. It joined Siberia to North America. 10,000 years ago, people found their way across. The first humans to set foot on American soil. Humans have only been here for a fraction of Alaska's epic history, but their impact on the landscape has been momentous and devastating. In the 21st century, climate change is gripping Alaska. Tom Douglas is seeing the evidence. Before his eyes, ice and snow are disappearing.
And the erosion rates have increased 5 times since the 1950s. Right now, they're eroding into the sea. This piece is actually dangling off into air in the summer.
And the signs seem to be everywhere. Why has permafrost, that's been frozen for at least 10,000 years, started to thaw? What's this doing to this awesome winter world? Adventurer Will Gadd and geologist Peter Heusler are searching for answers. The trail has led them to southern Alaska, on Lake George, at the foot of the Chugach Mountains. They're hunting for an iceberg because they hold the secrets of Alaska's past and a warning about its future. Wrapped up in these bergs are clues that could tell us just how serious global warming is. These icebergs start life as snow, turn to glaciers, and eventually crash into the sea. They mark the end of a glacier's life. Within them is air, trapped when this ice formed. A record of a time hundreds of years ago, before the climate changed. As the bergs melt away, that air is released. That's what makes them special to scientists. But bird climbing is one of the most deadly pursuits in geology.
Moment of truth.
Yeah.
What's gonna happen?
They can roll over with no warning. And this ice is so compressed, one tap can shatter it. Roll or split, either can bring hundreds of tons of rock-hard ice down on the unwary.
That was a big crack. Hearing some kind of weird noises. We're just gonna get out of here.
The evidence locked in these bergs is crucial because it shows that just a couple of hundred years ago, there was a staggering 30% less carbon dioxide in the atmosphere.
Air from hundreds of years ago, pre-industrial age, no pollution. Smells good.
This massive difference is a sign of a dramatic change that helps drive global warming. But hidden in this landscape is an even starker warning. Alaska's 100,000 glaciers are under threat of disappearing because they are super sensitive to the effects of global warming. To understand why, Will Gadd's going where few have gone before. This is a melt stream running over the lower reaches of the glacier. Will's on a deadly journey, not for him, for the glacier. Just starting this journey is a challenge because the streams cut deep into the surface of the glacier, leaving sheer walls. These roaring torrents are formed as glaciers melt on their lower slopes, and they're a vital measure of its health. Every glacier has a tipping point. The amount of snow falling in winter must equal the amount washed away each summer. If that balance tips towards the melt, the glacier will disappear. Right now, that's what's happening. Alaska's glaciers are melting faster than they're growing. Alaskan glaciers have been here more than 3 million years. They are currently losing ice at the rate of 80 billion tons a year. It's the end of the road for this glacier. It tumbles off the mountains and into the sea. Alaska's glaciers are retreating at an increasing rate. Every year, 19 trillion gallons of meltwater are pouring away and not being replenished. As the glaciers melt away, it's the rest of the world that's affected. Alaskan glaciers are melting so fast that they account for 10% of the rising sea levels across the entire planet. It's the most dramatic transformation this landscape has undergone since the Ice Age. Could these ancient ice giants be in terminal decline? And what does this mean for the whole ice system? The ultimate indicator of these catastrophic changes is redefining the very furthest borders of Alaska. Scientist Tom Douglas is out on the frozen Arctic Ocean, checking the condition of the sea ice.
We're here on the sea ice off of northern Alaska. This is frozen ocean right here. This sea ice drives Alaska's climate, and it's changing.
Much of the year, this ocean is frozen solid. But now things are changing. The sea ice is forming later and breaking up earlier. It's bad news. Not just for Alaska, but for the whole world. Sea ice keeps the planet cool, not because it's cold, but because it's white. It acts like a mirror, reflecting the heat of the sun into space. There's nearly 12 million square miles of ice on the planet, 3 times the size of the entire United States. That makes a very big mirror with an equally big impact.
You can just see how white it is. When the ice goes away, that dark seawater absorbs more of the sun's energy, and then the water heats up, and then less ice will form.
It's a vicious circle. With less white ice, more warming occurs, melting the ice further still.
In the last 15 to 20 years, the summer season gets expanded, so the ice freezes and comes in later every fall, and the ice melts and goes out earlier every spring.
The damage to the sea ice is already obvious here.
This is a crack that's formed here as the ice is kind of headed outward, and there's a general thought that as climate gets warmer up here, there'll be thinner sea ice and perhaps more of these cracks will form in the future.
And the effect has accelerated in the last 2 years. The loss of sea ice here has increased to 40 times the norm. If it carries on, it will disappear entirely.
If the sea ice were to go away, the Arctic almost like have a fever, and it would get warmer, and it would probably connect to the rest of the planet and affect it as well.
Alaska could become the place it was 50 million years ago. A warm wetland where forests grew. Hard to believe all this could disappear. To really comprehend the loss to this great wilderness, you need to get above it. This land was once covered by the Nick Glacier. For 50 years it's been retreating, revealing parts of the valley floor that haven't seen daylight for thousands of years. All that's left now is silt and sand, the ground-down remains of a mountain. Plants are beginning to appear where once there was only ice. Global temperature change that caused this destruction? Less than 0.8 degrees. That's how sensitive this ice world is to our changing planet. For 50 million years, Alaska's been changing. It's transformed into one of America's greatest treasures. An icy wilderness containing some of its most valuable resources. And global warming could change it again. Alaska could end up without snow, ice, or glaciers. And if Alaska's in trouble, so is the whole planet.